we're going to create our first fault tree. So we've launched Relarsoft BlockSim, and we are on the Home tab, and we can go under the folder called fault tree, right click, and we have two options. We got the analytical fault tree or the simulation fault tree. We're going to use the analytical fault tree. We'll be using the simulation in another example. Alternatively, as we are on the Home tab, we can click on this pull-down menu, and we can see here what analyses are available within the software. And among that, we got the analytical fault tree. So we create the analytical fault tree. We got a blank piece of paper where we can construct our fault tree. So we are on the fault tree tab, and we got the gates. We got a series of gates, simple gates or dynamic gates, and then we got the events, and we got the subdiagram. So we create the top event and say it's an OR gate. So we double click and we call it, say for example, top event, and the description is the, say, power supply failure. Power supply failure. So we are considering an hydraulic pump, one part of an hydraulic pump, and we are focusing on the power supply failure. And the power supply failure is, say, given by 3 events, and we just reposition them. And these events are, we labeled them simply as A, B, and C. So event A is no electrical power, no electrical power. Event B is a faulty wiring. And event C is motor failure. Okay, and we click OK. So we got our 3 events, independent events. We just sort of rearrange them, but we haven't assigned a failure distribution for each one of them. So we click on the first one, and on the right hand side, in fact, we see that we got this default cannot fail. So obviously we can't do a reliability analysis of something that cannot fail. So we can either insert a model. So we have a choice, plenty of models here. We have a variable, 2 or 3 parameters. We got a mixed variable, a normal distribution, log normal, exponentials, and so on. We've also got life stress relationship, Irene, Arrhenius, and power law, and then we have some other models that perhaps could be more useful for modeling costs. So we can choose, say, to insert a model, or if we have already created these models in the past, and we can go on and select existing one and say, for example, we assign the model A which created previously, and the model A is a variable 2 parameter. The scale parameter is 1000, the shape parameter is 1.5, so 1000 hours and 1.5, and we click OK. So we repeat the same process as we already created those for the faulty wiring and the model failure. So we go and select the B model for the faulty wiring, and the same things we do for the motor failure. Motor failure in this case is not a variable, it's an exponential with the scale parameter or a mean life, sorry, of 3,600 hours. And we click OK. Once we've done that, we're able to analyze our fault tree. But before we do that, it's worth, given that we are going to present the results on the diagram, it's worth presenting results at a time when it makes some sense. So say, for example, say 500 hours, and we can present the results in terms of probability of failure or reliability. Fault tree normally present their results in terms of probability of failure, so we'll stick to these options, and we click calculate. So we click calculate, and we can see here our results, our 3 events. So we have the results of our events at 500 hours, Obviously we can change and republish the results, and we can see the results at the top event. And if the formula for that would be, the formula for the OR gate would be something like that. So what we got here, we got the A, B, and C, A plus B plus C, minus A times B, minus A times C, minus B times C, multiply, added on to A plus A times B times C. So this will be, say, the formula for the OR gate, which will give us the results we've seen here, 0.429881. And we can obviously see the graphical results. So here we can latch on to the curve, and we can see the results as they vary in terms of probability of failure as the time progresses. And if we are interested in extracting some specific results, say at 1200 hours or any other value, then we can insert, say, probability of failure or probability of survival at 1200 hours. We can calculate, and we can otherwise get the probability of failure. And that's it.